Hello everyone, my name is Brandon Party. I am the developer of this intensity profile analyzer, developed under the guidance of Roberto Anderson Aguiluz for some work on Poisson ratio with hydrogels by Ariel Smith and Dominique Inocencio. The application of this work, as I mentioned, was for Poisson's ratio. However, it can be applied or used for any sort of peak fitting from Fiji data. Before we even get started with how to use the software, we need to make sure we have all the correct packages installed. This file here installed packages.py is supposed to take care of that for us. I know most researchers use Spider, so you can just open the file here and click a play button, or alternatively in the terminal, Python install packages.py. And of course it's going to say these are all already satisfied for me because I've been running the software. It may take a minute or so. There's not that many, so it shouldn't take too long. But while those are installing for you, let's get into a brief introduction of the purpose of this software.
Hello, my name is Ariel Smith. I am a fourth-year PhD candidate in the mechanobiology lab at UC Merced. My research involves determining 2 out of the 3 important elastic constants for substrates used in cell mechanics and mechanobiology experiments, such as traction force microscopy. Although the Young's modulus of polyacrylamide hydrogels and elastomers such as polydimethylsiloxane are well known, their Poisson's ratio are often overlooked or assumed to be 0.5, which means that the substrates are incompressible. However, that is not the case, and we decided to use a very simple static tension test method to determine both the Young's modulus and the Poisson ratio of our substrates. When using this method, we place 2 or 3 fiducial markers to track change in the longitudinal direction, while the edge of the sample is then used to track change in the radial direction. As we add weights to the end of our sample, the distance between these markers will change. In order for us to track those changes, we then use the Intensity Profile Analyzer, also known as IPA, created by Brandon, which is an interactive software that allows us to highlight an intensity peak, then use a Gaussian fit to find the minimum value of that peak. The difference between these 2 peaks shown here will help calculate the radial strain as well as the longitudinal strain. This IPA software has made it very simple and quick for us to analyze our data. Thank you.
Okay, now you are fully equipped with the knowledge of why we are making this software, and your packages should be ready to go at this point. So we're going to jump right into how to actually use the software. The file you're going to be running is this main Gaussian.py. You can open it up and then hit play, or my preferred method is just working in the terminal as a developer. Python main Gaussian.py and run it. So you're going to get this small little window that opens up with 3 questions to answer it. The first one is selecting the data file. By default, it opens the Fiji data directory here with the software. However, you can browse for anywhere else on your computer. And so we're going to choose this one. Quick note about the data, if you weren't already aware, this is data exported from Fiji. And there are multiple ways to export your data, different ways to format the columns. Please ensure that the columns are formatted in this exact way using width and length up here, because the software in this section right here checks for if the columns contain either width or length. The main purpose of that is to specify the color, so it's easier for you, the researcher, to keep track of which one you're working with while just looking at the data instead of having to go back and forth. So with that out of the way, the next one we have to enter is which columns we're looking at. So the columns X and Y will be columns 1, 2, 3, 4, as they're not 0 indexed. So here this is column 1, 2, 3, and so on. And of course we need pairs of columns because we have X and Y data. So the distance is your X, the gray value is your Y, X, Y, X, Y, so on. So we're going to just stick with columns. We'll do columns 3 and 4 first. And then if your file has multiple sheets, as you can see down here, we have 3. We're looking at sheet 2 currently. If you only have the one sheet in your file, you don't need to put anything here. You can just leave it blank and it'll know that you only have the one sheet. So we go ahead and hit submit, and we get the graph that pops up. Because here when it first opens, you have the top and bottom. They look the same when you first start, of course. And the top is where you make your selections, so you can click and drag anywhere to fully encompass the peak you want to look at. And you can see here on the bottom, it zooms in to match your selection. So this left edge over here corresponds to the left very edge of the box on the bottom. And of course, the right up top corresponds to the right on the bottom. And the black line is the Gaussian fit to this curve. Orange is the data, of course, and then we have two minimas being plotted. We have the Gaussian and the average. So the Gaussian is a better approximator of the local minima that you're looking at. However, sometimes the data is not super pretty and the Gaussian curve does not fit the data very well. So as a backup, the average minima is in place. Choose whichever you feel is more appropriate for your work. And of course, once you've made a selection, you can make different selections somewhere else. And on the bottom, we have the pixels. So the minima here is going to be 2779 length in pixels and a brightness intensity of 74. So let's look at some data where the Gaussian doesn't fit super well. So we'll look at columns 1 and 2, hit submit. You'll notice also now the data is blue. That is because we were previously looking at length columns here, 3 and 4, and now we're looking at width columns 1 and 2. The change of colors to help you keep track of which one you're looking at, either width or length. So here you can see a Gaussian is not going to fit super well. It likes to think the minima is on top over here. And this is where the average minima would come into play to give you a more accurate minima value at distance 2445 and intensity 115.9. And that is essentially the entirety of this software. If you have any questions on how it works or if something isn't working for you, please feel free to reach out to any of the researchers or me personally. I will do my best to assist. Thank you.